In this section, we want to start introducing exponential functions, talk about some of their characteristics and behaviors. We can start off by identifying exponential functions as functions of the form f of x equals b to the x power. We want to pay close attention when we're looking at functions because these can look very, very similar to power functions, which are functions of the form g of x equals x to the n power. The key thing to pick up on is where the variable is in that expression. For an exponential function, the variable is in the exponent. For a power function, the variable makes up the base of that expression. It's the value that's being raised to that power. And we'll also take a moment to focus on that word base. When we talk about an exponential expression, whatever that number is that's being raised to that variable power is referred to the base. So what we have here is a base b exponential expression. Taking a look at the graph of an exponential expression, here we have a base 2 exponential expression because this is the graph of f of x equals 2 to the x power. And then we also have graphed here g of x equals x squared. We have the same two values here in both functions, but we're switching their positions. Again, a number raised to a variable power is an exponential function. A variable raised to a number power is a power function. Now we can look at comparing and contrasting the behavior of these two functions. We can start off by looking at what happens to each function as x approaches negative infinity. If we look at our function f of x and trace along that to the left, we can see that f of x is approaching a value of 0. And actually what we have here is a horizontal asymptote. So our exponential expression, or exponential function, as x approaches negative infinity will get closer and closer to the x-axis, so closer and closer to a function value of 0 without ever crossing over that line. While our power function, x squared, or g of x, is approaching positive infinity. So a power function and an exponential function have different behaviors on one side, and then as x approaches infinity, we can see that those two behaviors, at least initially, appear very similar. F of x, our exponential function, is headed to infinity, and g of x, our power function, is also headed to infinity. The graph that we have pictured on the right is actually the graph of the exact same two functions, f of x and g of x, that we graphed on the left, but now we've zoomed out our view to see a little bit more what's happening as our x value increases. Again, we can see from the graph on the left that as x approaches infinity, both function values are headed off to positive infinity. But once we zoom out, we can see that that exponential function, f of x, is growing much, much, much faster. For instance, when we're at an x value of 10, our power function has a function value of 100, while at 10, our exponential function has already taken on a function value of 1024. So while we're zoomed in on the left, that behavior on the right seems very similar, but as we zoom out, again, we can see the exponential function growing much, much faster than the power function. And this is where we get the idea, if you ever have heard someone refer to exponential growth, or something growing exponentially, they're talking about very, very, very fast growth because that function value is increasing at a much, much higher rate than the power function g of x.